Celeste, LEO-PNT. Celeste is a future low Earth orbit positioning navigation timing, LEO-PNT, satellite constellation by the European Space Agency, ESA, intended to demonstrate the usefulness of LEO satellites for complementing and enhancing the services of higher orbit systems like Galileo or the European Geostationary Navigation Overlay Service, EGNOS. Launch of the first two satellites is planned for early 2026. Celeste was named after Maria Celeste, a 17th-century Poor Clares nun and a daughter of Galileo Galilei. Celeste will play a pioneering role in elevating the future of Europe's satellite navigation capabilities. As Europe's first initiative for satellite navigation in low Earth orbit, the mission will be testing next-generation technologies and add new frequency bands for satellite navigation. Celeste will demonstrate how a complementary layer flying closer to Earth can enhance Europe's current Galileo system in medium Earth orbit, MEO, boosting the overall resilience, enhancing its performance and opening opportunities for new service capabilities directly from LEO. The first two satellites successfully completed their test and qualification campaign and were formally declared ready for flight. The satellites are currently being shipped to Rocket Lab's launch complex in New Zealand, where they will undergo final testing and integration in the Electron rocket ahead of their launch no earlier than March 24, 2026. Similarly to the early stages of the Galileo program, Celeste will begin with two demonstrator satellites to secure the assigned frequency filings and to test representative navigation signals until the end of the year. The two satellites, Pathfinder A1 and Pathfinder A2, consist of two large CubeSats, 12U and 16U respectively, both developed by two consortia composed of a wide set of European players, one led by GMV, Spain, and the other led by Thales Alenia Space, France. Together, they will enable in-orbit testing of next-generation technologies, including autonomous precise orbit determination without reliance on ground infrastructure, as well as stronger and faster radio navigation signals in L-band and S-band from low Earth orbit. Over the past months, both satellites successfully completed payload integration, radio frequency compatibility tests, and environmental qualification, including thermal vacuum, mechanical and electromagnetic compatibility testing. 8 larger satellites with additional capabilities are under development, with GMV and Thales Alenia Space each responsible for 4 of them. Design and development are progressing steadily, with an opportunity for subsequent launches from 2027 onwards. The 8 satellites will build on the work of the first 2 satellites and demonstrate radio navigation with additional novel signals and new frequency bands. S-band two-way navigation signals, for advanced positioning capabilities using 5G satellite waveforms. C-band signals, for additional resilience against jamming and interference. Ultra-high frequency, UHF, band signals, for enhanced penetration and indoor positioning. On top of the 8 satellites, an additional one will include a payload to test miniaturized atomic clocks on board, along with other technologies, says Roberto Prieto Cerdera, ESA's Celeste project manager. Once fully completed at an orbit between 500 and 560 kilometers, 311 and 348 miles, the demonstrator mission will offer an ideal in-orbit test bench for a broad variety of downstream applications, such as autonomous vehicles, maritime navigation, critical infrastructure, polar and Arctic operations, wireless networks, emergency services, asset tracking and Internet of Things, IoT applications. By carrying out these experimentation and demonstration activities in orbit, we are opening a platform where ESA can work hand-in-hand with end-user communities and stakeholders to demonstrate innovative technologies in satellite navigation, push boundaries and demonstrate services in conditions that mirror the real world, adds Roberto. ESA is offering interested third parties from ESA participating states the opportunity to participate in the experimentation phase of the Celeste in-orbit demonstrator. More information is available on ESA's Open Space Innovation Platform. Following Celeste's in-orbit demonstration, Celeste's in-orbit preparatory phase, approved at ESA's Ministerial Council in November 2025, CM25, will focus on technology development, industrialization and in-orbit validation, preparing for a potential operational system as part of the European Union Global Navigation Satellite System, GNSS, infrastructure together with Galileo and EGNOS, also supporting potential commercial initiatives.